All right, let's do a little inequality systems here. So 7.7 are systems of inequalities. And this is, so we're going to be looking at this with two variables, meaning just like we solved equations with two variables, we're going to graph here in two variables. But think about what it is that we're doing. When I have a graph, right? If I have a greater than or less than symbol, that means up to but not including. It means the same thing whenever we graph this. So if this is up to and not including, this is going to be a dashed, well, I need to learn how to spell dashed, line. So up to that, not including, that's going to be that my graph is going to be dashed at that place. All right. If I have the or equal to, that means that is also included. If that is included, then it's going to be a solid line. Okay? Or whatever graph it is that I'm doing. Now here's the other thing. When you have an inequality, there's more than one answer, right? So some value, all of the values that are greater than or equal to whatever it is that you're looking at, right? So x is greater than 4. Well, there's an infinite amount of values that could fit that bill. Up to 4, but not including, right? So whenever I'm looking at this, use what we know about our graphs. When we have these graphs, if you have a function, which is all we're going to have. If you don't have a function, then you just test values, right? But if you have a function, then y, if y is greater than or equal to, or just greater than, right? Greater than or equal to, or, I'm going to write the word or in there so that hopefully that helps. Or just greater than this. So my y values are bigger than my function, whatever my equation ends up being. Then, where are the y values bigger? Like if I have this xy coordinate chart, if I'm talking about where my y values are big, then that's where I'm going higher and higher, right? So if my y is greater than whatever equation, parabola, polynomial, blah, 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 right? All of these different things where the lines, where my y value is greater, then I'm going to be shading above. Because that's where I have y values are getting bigger and bigger. That's going up. That's going to be above. All right. Now, what if I have y values that are, scoot this up a little, less than or equal to or less than whatever equation you have? Where are the y values getting smaller? Yeah, so if my y values are less than, that's going to take me below. Do you see where I'm getting at here? So if you have a function and I'm looking in relationship to y, if y is greater than whatever equation I have, I'm going to shade above it. If y is less than whatever equation I have, I'm going to shade below it. Make sense? All right, let's do some. So if we're going to graph this, then we have something along these lines. Here's example 1. X plus 4y is greater than 4. Now, I'm going to solve for y here. So I'm going to subtract x from both sides. I'm going to put that x closest to my symbol because I'm going to put these in mx plus b form. If I divide everything by a 4, y is now greater than a negative 1/4 x plus 1. This symbol tells me if it's either going to be dashed or solid. So what have we got? Dashed. Am I going to shade above or below? Above. Good, because the y values are bigger than this line. So the same thing that you graph any line ever. You know your slope is a negative 1/4. Your y-intercept is 0, 1. So I'm going to graph on here. I'm going to graph with blue because it'd be black on black otherwise. Up here at 1, my slope is down 1 over 4. Now, because this is an inequality, I'm going to fill up this graph. Because it's all kinds of values, right? This is dashed, so I'm going to write a dashed line here. And then I'm shading above. When you shade above, you don't have to get real specific, but just say where it is. In my math lab, they're going to have a little bucket. Then you're going to click that bucket and it's going to shade for you where you go, right? So you need to fill up this graph. When you're filling up this graph here, then you're going to, on your paper, like whenever you're doing your tests or something along those lines, you are going to have, if you give me some tiny little business like this tiny little line right here, and then just shade right here, that ain't right. So if that's not correct, that's not what we're going for. Literally, if this were infinite, it would go all the way here, and everything up here, this whole entire place is going to be shaded, right? Because these are all the values. There's arrows on these ends. It's infinite. You see what I'm getting at? So regardless of the limitations of whatever grid it is that you have, just know that this goes on forever, and then everything up here is what's making my statement true. All right. Okay, so I'll get off that soapbox, and let's do some more. Here, if I have, you can do 1, or I'm going to do an extra 1 here just because it's good to bring this back. It's been a while since we've seen them. What if I have y is less than or equal to 2x plus 1 squared minus 3? Oh, that's right, people. They do not go away. Whoop, whoop. We got ourselves a quadratic. Yes. So you get extra practice here. You are welcome, right? Yeah, cool. All right, we've got it already in vertex form, so let's rock the socks off this thing. I know that my vertex is opposite same as the name of the game. So -1, -3. I missed my negative sign there. -1 because it's opposite. Anything that's a horizontal is opposite. Then the -3 is the same. So then we do our x, y, new y chart. So my x values are plus or minus 1 and 2. My y values are 1 and 4. Then I have my a here is a 2. So we multiply those. 2 times 1 is 2. 4 times 2 is 8. I like to cross off those two middle ones because otherwise it confuses me. And so I don't like to be confused. So I'm going to cross those off. Then you graph your vertex. Well, let's get a little info here. This one is tell you that it's going to be a solid line. And if y values are less than that, then I know I'm going to shade below. All right, so let's do it right now. My vertex is -1, -3. I'm going to go over 1 here because it's plus or minus 1. So I'm going to go to the right one, to the left one, go up 2 and make a dot. Back 1, up 2, make my dot. Back to the vertex. It's always back to the vertex. Then I'm going to go positive and -2. So out 2, positive and negative, and then up 8. So over 2, over 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Back 2 and up 8. And this is solid. Remember your parabola is a curve, not, oops, let's try again. It's a nice curve. It's differentiable everywhere. And I'm shading below. Now, I like to do something like that here with shading below, because if I am going to shade this below, look at where the y values are smaller. They're down here, right? Which means that's going to be on the outside of my parabola. So in this particular instance, you just look at that vertex. Where is it below? Then that's going to be on the outside of my parabola. If it were above, that would be on the inside of that parabola. Do you see that? So just look and see, okay, where is my y-axis? Here it is. If my y-axis is in between here, then I'm shading it below. Like if I'm going up between, on the y-axis I shade in between. Here my y-axis is going down, is outside, so that I'm shading everywhere outside. Does that make sense? Okay. But this section is called systems of equations. So if I'm looking at a system of equation, you literally just do that. So if I have this example 3, x is greater than 6 minus 2y, and x squared is less than 2y. All right, so this top one here is a line, which we know, and the bottom one here is a parabola. It's that quadratic. So we're going to graph both of them, and where they intersect, that is our solution. Simple as that. Let's do this thing. I'm going to go red. So I have x is greater than 6 minus 2y. I'm going to add 2y so that I don't have to worry about my sign. So I have 2y plus x is greater than 6. Subtract x from both sides. 2y is greater than negative x plus 6. Divide both sides by 2. Y is greater than a negative 1/2 x plus 3. Right? If I would have kept my negative 2y over here, that would have been fine. You could have subtracted 6, but look what happens. Anytime you have this negative symbol with an inequality, you're going to have to flip the sign anyway. So you might as well just move this over and make it positive. It's back to that number sense that we talk about all the time. So now this one I know is going to be above and dashed. My y-intercept is 3. My slope is negative 1/2. So I'm going to go down 1 over 2 to get your line, up 1, back 2. So just graph your line like you guys know how to do. And I know it's dashed. And in this instance, I'm shading above. So I'm just going to put a few lines up there just so I know where it is. All right. Now, let's go with our parabola. Here is blue. X squared is less than 2y. To get that y by itself, I'm going to divide both sides by 2. So I've got this 1/2 x squared is actually less than y. Now, I don't really like having my y on the right side, so I'm going to rewrite this to be y is greater than 1/2 x squared. As long as your mouth stays on the y and my mouth stays on the y, then those are equivalent. Do you see what I mean? The mouth of my inequality symbol. Again, we're going to be dashed. And this one's going to be above. Now, what's up with this? If I don't have anything here next to the x and nothing back here, what is my vertex? Yeah, 0, 0, right? How cool is that? So my vertex here is 0, 0. Even whenever I still do my xy, new y chart, I'm going to do plus or minus 1 and 2 just because you always do. And then 1 and 4 because positive or negative 1 squared is 1. Positive or negative 2 squared is 4, right? We're remembering all this is coming back to us. My a value here is a 1/2. So 1 times 1/2 is a 1/2. 4 times 1/2 is 2. So from my vertex here of 0, 0, I'm going to go over 1 and just up 1/2. Back 1, just up 1/2. Over 2, up 2. Back 2, up 2. Now here's the thing in my math lab. Can you graph a 1/2? Probably not, right? So in my math lab, if you can't graph a 1/2, then what would you go for? The 2, exactly. So you don't have to do this very first dot on your paper, you can. But in my math lab, they typically do things that are on the actual grid because that's how computers work. Here, just do this value and do this value, and it'll graph it for you. Do you see what I'm saying? Okay, so this is dashed. And I'm shading above. Oops. Now, where do these intersect? Yes, they intersect up here. So in my math lab, when you go to do this, you are going to put a bucket where they're both shaded, right? Where this intersection with an inequality, there are many values that are intersecting. So here, I'm just going to shade where they both intersect, where they're both shaded, all right? On your paper for your test, whenever you go to do this, then you are just going to shade where you need to shade on your test. Do you see what I'm saying? So even on your paper, even if you make your own graph on there, just make sure you're shading and proving to me where that is. This is not something that you're going to be able to put into Canvas whenever we have our tests. You're going to have to do it on your paper, and that's where you're going to get your partial credit. Does that make sense? Okay, now remember, if you have any questions from any of these notes, bring those with us to our virtual session, and I'll be happy to answer those. Also, email me. Always, always, always feel free to email me. Use that Ask My Instructor in Canvas or in my math lab. I'm happy to help you guys. Communication is going to be key here. All right.